What's up, math fans? Today I want to do solving systems of equations, and I wrote graphically, although it's kind of natural to do it graphically. When I say the word equations, I meant to say inequalities. When you think of inequalities, you're thinking of greater than or less than, and what that means is if you're comparing numbers and you want something greater than 5 or less than 5, there's infinite amount of possibilities there. So when you're trying to solve inequalities, it's better to see it than to imagine it, because I'm imagining an infinite amount of answers. What could my answer be? So I'd rather see it on a graph. So I came up with two equations, and I'm going to want to graph them. So you might want to find your notes or my video on graphing systems of equations before you do systems of inequalities. In order to graph this, you need to be familiar with something that looks like this. This is a linear equation in standard form. Don't say this is slope. This is not slope. This is the form that every linear equation should be in. So if I look at something that looks like this, I know I'm looking at a linear equation. If I see y, good, I want y. I want y alone. Equals m. M is a number, it's a coefficient of x, whatever number it is. In this case, it's 2. Then comes x, then comes plus, then comes b. And b can be negative. So in this case, b is -4. So you won't see it as +4. You'll see it as -4. Or you might see it as plus -4, but that's rare. You'll usually just see it as -4. So I'm trying to think of a story that this could represent. Think about the little green boy. It's green because the equation up here isn't green, but the inequality is green. Think about the little green boy, and kind of green like my tie. Little green boy owes $4, okay? He owes $4, and then he gets a job that pays $2 per hour. This is my rate. That M, that's your rate, also known as slope. So the little green boy owes $4, but he gets a job that pays $2 an hour. So eventually he's going to get out of debt, and eventually he's going to make money. So we're going to see what that line looks like. So this equation represents the little green boy's savings, okay? Now, think about the orange equation. Here's a story for that. And that's y equals 8. I'm just converting them to equations, because if you can do it with equations, you'll be able to do it with inequalities. So y equals 8 just means the boy has $8. That's it, the end. Okay? So it's a lot simpler, less of a story here. But again, this number is the slope, this number is the y-intercept. So notice in this story, there's only a y-intercept. The boy has $8. There's no slope, there's no rate. So if you wanted to be annoying about it, you could write it as y equals 0x, you make no dollars per hour, plus 8, you just always have $8. If you remember this, it'll be easier to graph. So y equals 0x plus 8 is the same as y equals 8. So I'm going to graph that over here. I'm going to graph it in orange because it matches this, all right? Y equals 8 on the y-axis, find 8, draw a point. But y could be 8 over here to the left, y could be 8 over here to the right. I actually have a video describing horizontal lines. If y equals something, it's a horizontal line. Try to use a straight edge. I'm sorry I didn't use one. I'm in a rush. So I got my horizontal line, y equals 8. But this says y is less than or equal to 8. So think about the little green boy. He has a job. He's going to want to get lunch soon, but he refuses to spend more than $8 on lunch. So he wants to spend less than or equal to $8. He'll spend 8, he'll spend less than 8, he won't spend more than 8. So show me all the numbers that he's willing to spend. What is less than or equal to 8? 7, 6, 7, 6, 5, 4, 7, 6, 5, 4, 7, 6, 5, 4. He's willing to spend anything below the line, anywhere below the line. Now, technically, in the negative numbers, he's not going to spend negative dollars, but for the purpose of a graph, if it's a pure math question and not a real life situation, you're going to see a shading below the line showing infinite amount of possibilities. Anything less than 8, he'll spend $0 on lunch. He'll spend negative dollars on lunch if it was a pure math question. In real life, you're not going to spend negative dollars. Okay? So that's it. This is how you graph an inequality. Y is less than or equal to 8. And hopefully this throwback will help you. How do you graph this? Well, you start by graphing it This way, you start at the B and then you do the slope. You start at the B, so I should start at -4. 1, 2, 3, 4. Put a point here, and then what's my slope? My slope is 2, also known as 2 over 1, which tells me to go up 2 over 1. Up 2 to the right 1. Always graph to the right. So from here, I'm going to go up 2, and if you have graph paper, it's a lot easier to count. 1, 2, and then over 1. So I'm right here at 1 comma -2. I'll do it again. Up 2 over 1, now I'm at 2 comma 0. This time, get your straight edge. I'll get mine. And the green line continues forever. Now you notice they intersect right here, but this point is not as important as it was back when it was just linear equations. When it was system of equations, that point that I circled is called the solution, and you're done. But for shading, for inequalities, when you're shading, you gotta do a little more. So now the green line is here. Let's say the boy is willing to spend more. This is how much he earns. He's willing to spend more than he earns. He's willing to put this lunch on layaway. He's willing to borrow money to spend even more than what he actually earned. He's willing to go broke and spend more. So this is what he earns on the green line. He's willing to spend more than that, so you just shade above. Shade above. Shade above, 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 above the line. Okay? And that's really it. That's a shortcut. Greater than means shade above, less than means shade below. There is a way to prove that. You just pick a point that's above the line. Any point, and the most famous point is 0, 0. Take 0, 0, plug it in here, and see if it comes out true. 2 times 0, 0, minus 4 is -4. But I put a 0 here also. Is it true that 0 is greater than or equal to -4? It is true. If it's true, you shaded the right way. If it's false, you should have shaded the other way. But I know it's greater than, so I'm going to shade up. All right? So this is the picture of the solution. Now think about what the solution means. If this is a Regents question, they might not ask you what the solution means. They might just ask you to put S for solution or S for Superman. Let's see. Anywhere the orange and the green cross is an S. So you would put a big ol' S right here and you're done. The orange is alone here, so that's not part of the solution. The green is alone up here, that's not part of the solution. Only here where they both crisscross, that is the solution. Then you pick any point you want inside that shaded area, like 0, 0 would absolutely work. But let's say this was a real world question and they say, well, how much is the boy willing to pay? So I would pick an answer from this area right here, anywhere here. So let's say 1, 2. So here's a possible solution, 1, 2. All right, notice there's infinite amount of solutions there. Just pick one possible solution. Don't believe me? Plug it in. Is 2 greater than or equal to 2 times 1 minus 4? So this is x, this is y. I plugged in 2 for y and 1 for x. Is 2 greater than or equal to 2 minus 4? Is 2 greater than or equal to -2? Absolutely. So I picked the right solution. 1, 2 is right here, by the way, which is clearly inside the shaded region. So I did a great job. Hopefully you follow that. If not, rewind it, play it again. All right? Graph line, shade. Graph line, shade. Find a point in the intersection and you're good. Thanks for watching. See ya.